All right, Ella. So we're going to go ahead and we're going to look at this activity together. I would like for you to try it on your own before you watch this video. But if you get stuck, this video is here for you and to double check your work too. All right, so what I've done to start with is I've put all of kind of my words up here at the top just to kind of make it easier for myself. And then all of my symbols and things down here. So let's take it one at a time. So we're going to go ahead and start with this symbol. We know that this symbol means it's greater than or equal to. So we're going to go ahead and attach that. And notice that it went up here. That means I'm right. All right, we know that this symbol means less than or equal to. So we're going to go ahead and attach that. My score is going up. That means I'm on the right track. We know this symbol means less than, and this symbol means greater than. Cool. All right, so we're going to look at the next one. The next one is this. It says caution, maximum load, 500 pounds. We know the word maximum means that it could equal 500, but it cannot be more than that. It has to be less. So we're going to use less than or equal to 500 pounds. My score is going up. All right, the next one's kind of tricky, but notice how the coffee is pouring out of the cup. We have more coffee than cup. So we want to use the greater than symbol. All right, we're doing good. Next one, speed limit. We know in a speed limit, we could go 55 or less. We cannot go more than 55. So we need to use less than or equal to. Okay, I've got a couple. I'm going to move them so we can see them all. Got one hiding over here. Oops. Oops. Detach. There we go. Okay, I've got one over here. All right, here we go. So let's look at this. It says from agent install to mean time to know in less than 5 minutes. So it's right there and there, less than. Okay, my score's going up. This symbol has it right there. It's the greater than symbol. 5 is greater than 4. Okay, next one, minimum fine. We know minimum is the opposite of maximum. So the least amount that you'll be charged is 250. 250 or more. So greater than or equal to 250. All right, we've got one more, I think. We've got this guy. It says you must be at least this tall to ride. You can be taller, but you can't be short. So we're going to say greater than or equal to. We're going to try to attach it. One of our other students had an issue with this earlier. So let me see if I can move it up maybe. And attach it. It's being tricky. I'm not sure. There we go. There we go. There we are. Oops. Something has happened. Oh, there was 2. This one was hiding. All right, so we know that this is greater than or equal to. And this one, you must be shorter than this to ride. So you cannot be equal to that line. You have to be less than that line. Now we have all our cards correct. So we're going to go ahead and check yours. Make sure you've got all of these for each of them and move on to the next slide. Okay, this one looks like a lot, but it's not too bad. Okay. So again, I'm gonna start by putting my symbols at the top, I think. So I'm gonna put greater than, greater than or equal to, get rid of that one. And I might have to move some around, and that's fine. Less than or equal to, and less than. Okay, so I have all my symbols at the top. Now I'm gonna sort my words, okay? So the first one says higher than, okay? So higher than sounds a lot like greater than, so I'm gonna use that symbol, greater than. We got 2. All right, let's keep going. Cannot spend more than. So you have to spend less than, or you could spend equal to. Cannot spend more than. You know, this one was marked wrong in class too, and Miss McCall and I had a discussion, and we both thought it was less than or equal to, but they're going to tell you that it's less than. Cannot spend more than. We got a 4. All right, this one's easy, less than. Pretty simple for that one. All right, let's move some so we can see. Must exceed. Exceed means to be more, and it must be more than. Must exceed. All right, this one's more than. It's easy. Greater than, we know is the same one as more than. We're doing good on our amount. Fewer than, we know fewer means less. Less than. Least amount, the least amount that you could do. So we want less than or equal to. Ah, they're telling me that's wrong. So let's try less than, least amount for less than. Nope. You know what? I think least amount means that you could have more. So let's try over here. Yes, that's correct. All right, so we know that least amount is like the smallest you can do, but you could also do more than that. So least amount is greater than or equal to. Less than or equal to, self-explanatory. No more than. You could have less than, but you can't have over the number. You could have equal to, so you want less than or equal to. All right, greater than or equal to. It's pretty self-explanatory. Let me find it. Okay, cannot exceed. We know exceed means to go over, so it cannot be more than something, but it could be equal to. Oh, again, they're having that same problem. Cannot exceed is the same thing as cannot spend more than. Let's put it there. All right, no less than, must be greater than. Oh, Miss Jessie's having a hard time with this. No less than. Greater than or equal to. Perfect. At least means you could have more, but you couldn't have less. Greater than or equal to. Two more. At most. So if at least is greater than or equal to, we know at most is less than or equal to. Oops. There we go. And one more. Greatest amount. Greatest amount. I'm going to say is less than or equal to. All right, so we got through that. That was kind of tricky. I do not have an answer key. So we have all of our keywords for each of our inequality symbols. So go ahead and check yours with mine, make it match, and move to the next slide. All right, so what I did with this one is I moved all the word problems in like a row. I moved some of the inequalities over so I could see. There we go. Okay, so let's read the first one. Gamora was overdrawn $350 and deposits $200 a week. Captain America has $25 in his account and deposits $35 a week in his account. How many weeks until Captain America has the same or more than Gamora? All right, then. So we're looking for Gamora being overdrawn $350. Okay. So she is overdrawn $350. That means that she has taken too much money out of her account. She's overdrafted. Okay. So she overdrew $350 and deposits $200 a week. So we're looking for something that uses subtraction symbols to show that she's overdrawn. And then we're looking for something that shows $200 per week. So we're looking for $200 and a variable. Okay, we're looking for that for Gamora and for Captain America. But Captain America looks like he has not overdrawn his account. Captain America has $25 in his account and deposits $35 a week. All right, so that was a lot. So let's look for somewhere where it's 350 overdrawn and deposits $200 a week. Captain America has $25 a week, or $25, sorry, in his account, and he deposits $35 a week. So I think right here is our inequality. Yes, that was correct. All right, so we're just going line by line. We're translating. Okay, Spider-Man has $350 in his account and is earning $25 a day. Shuri has $200 in her account and earns $35 a day. How many days will Spider-Man have as much as or more than Shuri? All right, so we're looking for somewhere where Spider-Man has $350 and is earning $25 a day, and Shuri has $200 in her account and is earning $35 a day. This is our inequality for this one. Okay, let's Let's keep going. Ant-Man is overdrawn $350 and deposits $25 a week. Wasp is overdrawn $200 and deposits $35 a week. How long before the Wasp has as much as or more than the Ant-Man? So again, they're overdrafted. They have taken too much money out of their account. So we are looking for numbers that are using subtraction or negative numbers. So it says Ant-Man is overdrawn $350. Okay, it looks like this one's overdrawn $350. Look how there's a subtraction. And deposits $25 a week. Looks good so far. Wasp is overdrawn $200 minus $200 and earns $35 a week. This looks like our inequality right here. Wonderful. All right, so the last one only has one left, but let's go back. There we go. Let's look at it anyway. Deadpool has $350 in his wallet and bought toys for $35 a piece. Thanos has $200 in his wallet and sells toys for $25 a piece. How many toys must be sold so that Deadpool has as much or more than Thanos? Okay, so let's look at this. Deadpool has $350 in his wallet, a positive $350, and bought toys. So when you buy something, you're giving away your money. You don't have it anymore. He's buying toys for $35 a piece, or $35 each. Thanos has $200 in his wallet, a positive $200 in his wallet, and sells toys for $25 a piece. So this time he's selling them, which means that he is getting money. Okay, Deadpool is giving away money when he buys things, and Thanos is getting money by selling them. So this is our inequality right here. Oops. And we have 8 out of 8. Check your answers, make them match mine. Move on to the next slide. Okay, let's keep going. All right. This one only has 3. Regina purchases a new cell phone. Her first option is to purchase a plan that charges $40 per month, and she receives a phone for $30. The second plan charges $50 per month, and she receives the phone for free. After how many months, X, will the first option cost less than the second option? Let's go line by line. She's purchasing a phone. Her first option is to purchase a plan that charges $40 a month, and she receives the phone for $30. The second plan charges $50 per month, and she receives the phone for free. All right, so I think this is our inequality right here. Line by line looking at it, looks good. All right, a fitness club offers 2 membership options. The first option has an initial fee, that means there's a flat fee of $50, and then charges $30 per month. The second option has no initial fee, but charges $40 per month. After how many months will the first option be a better value than the second? This one's pretty self-explanatory because only one of them has a flat fee of $50, and it's this one. Okay. Lila is looking into alarm systems for her home. Company A offers a plan that has an initial flat fee of $40, then charges $30 per month. Company B offers a plan that charges $50 per month. After how many months of X will Company A cost less than Company B? Okay, Company A has a flat fee of $40 and then $30 per month. Company B charges $50 per month. So it is this inequality right here. All right, check yours with mine and move on to the next slide. Okay, we're almost there. All right, number 10. Cami and Jorge each begin saving money for a new computer. Cami saves $5 per week. I think I can write on this. $5 per week. Yes. Plus $50 she receives for her birthday. So let's see if we can find that down here. Cami saves $5 per week plus $50. Jorge saves $7 per week. Jorge's saving is $7 per week. Which of the following can be used to find W, the number of weeks, that's our variable, until Jorge has saved at least the same amount as Cami? All right, so let me go back to my little selection tool here. Okay, so we've got $5 per week. $5 per week plus $50 she receives for her birthday. Which of the following can be used to find W, the number of weeks, until Jorge has saved at least the same amount as Cami? So what that means is Jorge could be saving more than Cami, but he has to save at least how much she is. So it is not equal. I do not want to know when they will hit the same exact amount. That doesn't matter. I want to know when will he hit the time where he has saved at least the same amount as Cami. We're going to click this one. Letter C. It's not the C, but there's A, B, and C, and it'll tell you if you're right. It says excellent. All right, let's do the next one. Let me erase my little lines here. Oh, goodness. Doesn't give you a good eraser, does it? Line by line. All right. Okay. Let's try this again. Get a pen tool. Okay. An animal shelter conducts an annual fundraising drive. The animal shelter must raise at least enough money to cover their annual rent of $2,500 and weekly expenses of $450. So far, the shelter has received a one-time donation of $125 and pledged donations, that means people saying that they'll pay that much, of $680 per week. Which inequality can be used to find W, the number of weeks it can take the shelter to meet the goal? So W is our variable, number of weeks. Okay, so let's look at all these numbers. It looks like so far we know that it costs them $2,500 plus their weekly expenses of $450. Okay, so let's look down here and let's see what we can find here. All right, so we want to make sure that we are covering that $2,500 plus the weekly expenses of $450. Okay, so it looks like there's really only two options it could be. Well, it really only looks like it's one option, right? Because we got a flat fee of $2,500 and we've got a flat fee of $2,500. So we've narrowed it down to 50-50. Okay, so let's keep reading. So far, the shelter has received a one-time donation of $125. Both of these have that one-time donation of $125 and pledged donations of $680 per week. Both of those have that too. Which inequality can be used to find W, the number of weeks it can take the shelter to meet their goal? Okay, so we want to make sure that the amount that we are raising is greater than the amount that we are going to have to spend. Greater than or equal to. We have to at least make that much, right? So I think the correct choice is going to be 680W plus 125 is greater than or equal to 450W plus 2,500. Correct. That is a lot of words, but we got there. All right, so let's go ahead and I think I can delete it without, no, I don't want that. Cancel. Okay, I think I'm just going to have to erase it. Give me a second here. So D was our answer for number 11, the slide 11. Our answer was 680W plus 125 is greater than or equal to 450W plus 2,500. All right, almost there. Okay. All right, next. Select that button and do the next. Okay, Mr. Johnson is grading science fair projects for his 26 students. He plans to spend the same amount of time grading each student's project. Oop. Lots of erasing left to do. What happened? Just erase the ones that are close by. Okay, Mr. Johnson is grading science fair projects for his 26 students. He plans to spend the same amount of time grading each student's project. He must also spend 30 minutes averaging and recording grades. I'm going to underline 30 is important and 26. 26. If he can spend no more than 500 minutes total on grading and recording, which inequality best describes the amount of time M in minutes that Mr. Johnson can spend grading each project? All right, girl, let's look at this. Let's get our little selection tool. All right, so he's telling us that there are 26 students, and he has to grade for each of them, okay? And our variable is M for number of minutes. So we know that each of the students he must also spend 30 minutes averaging and recording grades. So that is like a flat 30 minutes, no matter what, okay? So we're not going to have the variable with the 30 minutes because he's not like 30 minutes for each kid. He's going to take 30 minutes total for all the kids. So we're going to add that. So that brings us down to two choices. We've got the last one or the second one. So let's keep looking. He has 26 students. He plans to spend the same amount of time grading each student's project. So we have 26 students multiplied by the number of minutes we're trying to figure out. Okay. He can spend no more than. So thinking back to our keyword chart, no more than means we could equal this amount of minutes, 500, but we can't go over it. So we need 26M plus 30 is less than or equal to 500. B. Make sure your answer matches mine. And I'm going to go ahead and erase all of my markings. Our answer for number 12 was B. I'm just erasing. Okay. All right, let's go to the next one. Oops, I need my selection. Okay. I think we've got two more, and we're done with this activity. All right. Oh my goodness. Erase this. Okay, there we go. All right then. John has to deliver packages for a mailing service. He has to deliver the same number each day on Monday through Thursday and 10 packages on Friday. If John has to deliver a minimum of 135 packages a week, which inequality best describes the least number of packages X he must deliver on Monday? All right, so let's look at these important numbers. It looks like he's got Monday through Thursday, so that's 4 days, right? Monday, Tuesday, Wednesday, Thursday, Monday through Thursday. I'm just going to make a little note that that's 4 days. And 10 packages on Friday, so that's like that flat fee. No matter what, he has to deliver 10 packages on Friday. He has to deliver a minimum of 135 packages a week. Which inequality best describes the least number of packages? X. Number of packages is our variable. He must deliver on Monday. All right, girl, let's look at this. So it looks like we're going to start Monday through Thursday. We have like this. That's what we're kind of seeking, our variable, right? Our number of packages for Monday. So we really want that 4x to start us off because we have 4 days a week that we're figuring out. We already know what Friday is. We have 4 days a week. So we want that 4x. That gives us this one or this one, A or C. Okay. And 10 packages on Friday. And both of those have that flat 10 packages. Got it. All right. John has to deliver a minimum of 135 packages a week. So that is the least he can deliver, but he could deliver more. Okay. So we're going to look over here. He could deliver more than 135. So we want to make sure our inequality shows greater than or equal to. Okay, so our answer is going to be A. 4x, 4 days a week, plus 10 packages is greater than or equal to 135 is your answer. All right. We're all done. That was the last one. Thanks for watching.